Good afternoon. My name is Kenny Watson. I work for Roscoe Brown Heating and Air Conditioning out of Murfreesboro. We have an office in Nashville and Tullahoma. And give you a little bit, I'm the operations manager there. I'll give you a little bit of history on me. I've been in the business since I was 17, started out crawling under houses, doing duct work. Started my own business when I was 22 years old, kind of young, didn't really know a lot about what was going on. But when I was in business for myself, we started working for a company called Watt Count. I don't know if any of you remember Watt Count, but the three guys that started that company were all NASA space engineers. And they figured out when the space capsules could come into our atmosphere and out of our atmosphere at those extreme temperatures, why can't we control the temperature in a house? You know, pretty simple. So a lot of what you've seen today, this happened back in the late 70s and early 80s. What they did is they took total control of the house. The builder would pay 65 cents a square foot to Watt Count. Watt Count would go out. They would seal all the penetrations. Put up, at that time they were putting up a foil radiant shield. They would run loads on the house, size the equipment, and design the ductwork. So me as a contractor, all that was given to me, and I was pretty skeptical about it at first because I was used to doing houses at 500-600 square feet per ton. They were doing them at 1,000 to 1,200 square feet per ton. You know, they convinced me to go with the program, put everything in right, and it worked. Ultimately, they could guarantee the homeowner the utility bill. Put a yard sign out in the front yard. This house is guaranteed not to exceed, on the heating and cooling portion, you know, $34 a month, $52 a month, or whatever. And we would separately meter the HVAC equipment. And the homeowner would get a postcard that they would go out and read their meter once a month and send that information in and keep track of it. Because if it started going, looked like it was going over in the database, then something was wrong. Maybe the unit was low on Freon, something was going on because it wasn't performing up to the specs. But that program was very, very successful back in our first energy crunch back in the Carter administration. In 1985, I went to work for them. They recruited me to come on. I was doing a lot of the work, so they were expanding and growing, so I went to work for them. And my job was running load calculations. So I've run thousands and thousands of load calculations. At one time, we had 32 franchises all across the United States. And I was getting plans in and running load calculations and designing duct work for all those centers. Then the energy costs started coming down and the energy business is starting to tail off a little bit. So wasn't as important anymore. Then I left there. I went to work for a wholesale distributor in Nashville. I worked there for 6 years. And then I had an opportunity to go to work for Roscoe Brown. So I've come full circle. I'm back on the contracting side now. But my experience with the manuals is I'm on the Manual J committee that designed the Manual D, S, N, and the zoning manuals. So I got pretty good background on that. I'm on the mechanical board in Nashville, and I'm on the board for the local ACA chapter. So I can tell you, you know, if you do the things right, it'll work. A lot of you are skeptical, just like I was. You know, when you're getting out there and it's going to be 8, 9, even up to 1,000 square foot per ton, because that's been the problem in the past. There's been no quality control on the construction side. The air leaking, poor insulation, and those type things. So if the unit doesn't cool the house, who are they looking at? Looking at the HVAC contractor because it's not cooling. So I'm one of you. We typically would oversize the equipment intentionally to compensate for a lot of the quality control that was not going on out in the field. But now with the energy codes, you got building inspectors looking at those things just like Watt Count was doing. They're doing exactly the same thing, making sure the quality is there. I mean, insulation was not applied properly. They would tuck it in behind the wires. You know, we made them split the bat, half on the front, half on the back. they push it in behind the switch boxes or outlet boxes. We make them cut a block out so that insulation can puff out and fill the cavity full. You go look out, they want to push it in. It has the craft back on it. They push it inside the stud and nail it on the side. Well, you got gaps and voids there. T's and corners did not get insulated. Still may not today. So all that's going to be taken care of with the energy codes. So running load calculations today, you need to believe in it, do it right, and get the equipment sized right. And it's a big benefit for everybody involved, the homeowner especially. There should be some savings, and I'll go through a few of the slides here. First one I'll show you is, why do we have codes? Why do we need codes? You've heard of the where's my well, I lost my slide here. Well, I'll find it in one of the breaks. So we'll go ahead and get started on the first slide. Okay, I'm going to talk to you today about the abridged edition. What happened is in 1986, this was the manual J that everybody was using. Some people still use this, the 7th edition. You can see how many pages, that was. This was the 8th edition that came out. And we got a lot of flack, for that. I mean, you had to almost be a mechanical engineer and have software to learn how to use that particular book. A lot of changes in building components and things. So we came out with what they call the abridged edition. So it kind of in the middle of the big book and the other book. So the abridged edition is what we're going to talk about today. This is the one that's most widely used throughout the country. And you can kind of compare it to doing your income taxes. If you could only do the 1040 long form, a lot of people don't need that. If you don't have a lot of investments and deductions and things like that, you can run the 1040 EZ or the 1040 with very few schedules. So that's what we're saying. This is the long form. If you got a very, 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 very complicated house, you probably need to run the load using the big book. Otherwise, the abridged edition should take care of everything that you need to handle on it. Okay, long-term success in the residential comfort system depends a great deal on how well system capabilities match customer expectations. To accomplish this, contractors must work with the client first to establish realistic expectations, and second, to install a system that performs to those expectations. So are you homeowners here? Will be. Okay. That's what this means. If I'm an HVAC contractor, we sit down and we talk about, I don't want it to come up, well, it won't do this or it won't do that. We want to talk about everything, that's going on. I'm going to design the system to 95 degrees outside. That's our norm. Yeah, it's going to get to 100 degrees like it did this summer. It's a short period of time, but we don't put air conditioning systems in for that small amount of time. It's just like they calculate what size engine needs to go in a car to get the maximum gas mileage and efficiency out of. That's what we're trying to do here as well. So these systems are made to run continuously. Oversized systems, they start and stop, and that's what wears them out. So there's premature failure on systems that are oversized on it. So meeting with customers like you across the kitchen table or wherever, discussing everything, all your options. That's what this is saying here. During the client interview, you have the same vision. Temperature on each floor if it's a multi-story house. If you put one system in and you got one thermostat, it's going to be very hard to maintain the same temperature on 2 different floors or even a bonus room that's up over our garage. So you need to think about zoning or multiple systems in that situation. Uh, some of the newer technology, the variable refrigerant flow systems that are out now. I mean, in Europe and Asia, that's pretty much all they use, or the mini splits we call them. But now they have small ducted systems. So you could put like one 4-ton condensing unit out there and put a small ducted unit on the master bedroom and catch the master, the bathroom, and the closet. Then you put another small ducted air handler, catch 2 more bedrooms and maybe a foyer, another one in the dining and kitchen area. So you can zone the house using these small variable refrigerant flow systems, eliminating a lot of the duct work and giving much, much better zoning capability using one condensing unit. Otherwise, if you've got a 4-ton system and you got a 1-ton zone and it's calling for cooling, what are we going to do with that other 3 tons of airflow? Bypass it? Not a good idea. Dump it? Probably not a good idea. So it's not very energy efficient to zone a system like that. So make sure the homeowner knows, especially if it's, like I said, if it's a basement or a 2nd floor or a bonus room, the temperature differences that could be on each floor. Humidity control, very important, and getting the system sized correctly. If the unit does not run, it does not remove humidity. And humidity is occurring all the time, regardless of the outside temperature. So we've got to have some run time on the equipment. We found out also that Honeywell makes one of their Vision Pro thermostats that's got dehumidification control in it. And what that'll do is when it hits its set point of, say, 72 degrees, it'll continue to run no more than 3 degrees, removing humidity, trying to hit that humidity set point as well. And we put data loggers on one, and it ran to 3 degrees, then it started running 2 degrees, 2 degrees, 2 degrees, then it started running 1 degree, until it got that temperature and humidity exactly where we wanted it. So that dehumidification thermostat that Honeywell makes is a nice little feature that you could use as well. Costs just a little bit more, but probably well worth it in the long run. Filtration and air quality, need to make sure there's, you can go from a standard throwaway filter to a 1-inch pleated to 5-inch, high efficiency filters. Make sure you give the homeowners those options of what they want to do. Systems efficiency and operating costs. Once you run your manual J load calculation, we've got another program where you can feed those numbers into it, and then you can show the homeowner what the operating cost will be for a 13 SEER entry-level system versus a 15 versus an 18 versus maybe a 21. And you can show them the return on their investment. And most of the times they can put money in their pocket by upgrading to the equipment. Unlike the granite or the cherry cabinets, or whatever, they don't pay back. You spend money for that. You spend money here, and then we can show them where they'll get their payback on that. We show it both ways. You're either going to take money out of your pocket and do it, and we show you the return on the investment, or if you're going to borrow the money, I can show you percentage-wise I'm paying 6% on a loan, but I'm making 9% on an investment. So it's a no-brainer to go ahead and invest in that upper-level equipment. And one of the problems we have as HVAC contractors is the builders do not give us that opportunity to get in front of the homeowner, to offer them upgrades and choices like this. It's a kind of a hard sell. Health and safety issues. If there's asthma, in the family, we've got to consider any mold, mildew, backdrafting issues. And finally, building code compliance. Sometimes the homeowner may want to do this or that, but we got to say, well, we've got to comply with the code. We've got to comply with the code. And sometimes the way we have to install it, or the way we have to run duct work, or the way we have to place registers, like we can't put that return grill in the kitchen, close to a cooktop or something like that. So we have to make sure we do our code compliance. The system capabilities. System must be compatible with the negotiated list of performance criteria. We talked about this, the system concept, how many zones do we want? Maybe you have a customer that does a lot of entertaining on the weekends. They say, well, I want a little extra capacity there. Maybe that's a good application for two-stage equipment. That way, If the doors are opening, a lot of people, it'll run at high speed. Otherwise, when the load's not there, it'll run on the lower speed. So maybe good application for variable or two-stage equipment on that. The benefits of an accurate load calculation. It provides specified comfort and humidity at the design conditions. And that would be, make sure they understand that. It's at 15 degrees outside or 95 degrees in the summer. That's our design conditions. And we will exceed those. But we don't put an air conditioner in for that very few hours that it hits that. We want to provide acceptable comfort and humidity at part load conditions. On that 80, 85 degree day where we still need air conditioning, and remember I told you it's not removing moisture unless it's running. So you're kind of looking at airflow in there too, adjusting your airflow to try to squeeze as much moisture as you can out in the part load conditions. Provide reasonable comfort at outdoor design conditions. And there's some key words in here, reasonable. You have to reason with the homeowner why it can't do this or why it can't do that. Reduce the possibility of indoor mold and mildew. That's going back to removing the moisture out of the system. Real important. I'll show you. Here's out of the Nashville paper right here. It says, firefighters win suit over mold at work. 2 firefighters and their wives were awarded $76,000 by a judge after claiming that mold in a West End fire station made them sick. So there's lawsuit after lawsuit after lawsuit these days about mold. So gotta control the moisture, and that was discussed a lot in the first session about getting the moisture right. And this is all from sizing the equipment correctly too. Optimizing the install cost. Normally, if you run the load correctly, instead of it needing typically, rule of thumb, a 3-ton unit, you could probably get by with a 2.5-ton unit. A little bit cheaper to install, maybe a little bit smaller duct work. It operates better from an operating cost as well as just the equipment itself. We talked about reducing the operating cost and reliability because it needs to run. Starting and stopping is not good. They need to run. We talked about that. Translates to smaller equipment. The author of Manual J has a 2,700 square foot house with a 2-ton unit on it. He's done everything correctly by the book. And now that's hard to achieve if you don't have 100% control over it. But he was there when his house was built, and he designed the system and put it in. And he's doing 2,700 square feet with a 2-ton unit. We talked about that. Smaller ducts increases your duct system efficiency and cost. Minimizes the service loads imposed on the utility. TVA, they can't build power plants, so they're out just like everybody to try to reduce the load on the power grid. And that's where eventually the energy codes are going to come down and be mandated at the federal level, because that's why we're in wars today, because of oil. And we got to reduce our dependency on that, so we've got to reduce our energy consumption to a certain extent. So I think you're going to see an acceleration of the minimum requirements. I know Tennessee's a little bit behind right now. We're at the 2006 on the energy code and 2009 on the building code, and the 2012 is already out. So I think that's going to probably come from the top down, and it'll push that up the ladder a little bit quicker in the future. We translate to competitively priced proposals and quotes. So if your competitor is quoting the 3-ton unit and you're quoting the 2.5, a little bit smaller duct system, you're going to be more competitive and probably get the job. Minimize surprises after the system is put into operation. This is you can design the best system on paper. You can run the load calculation, you can draw up the best looking duct design, run the manual D, but the guys in the field can screw it up totally. So that's kind of what this means. You know, get it designed right, but you've also got to make sure that it gets installed right. We've got contractors in Nashville that they hire a truckload of, you know, Hispanic installers, and all they have is 6-inch flex and 4x10 boots, and it's all tied to the top of a vehicle, and they go put it in that way. No, just put a 6-inch run in every room or 2 6-inch runs. So make sure your installers do the right thing too on the install side of it. Demonstrates due diligence in a court of law. In the event, I've been an expert witness 3 different times in a court of law, and every time we can show the manual J, load calculation on the house, and proper ways to install it, and all 3 times it's been in our favor on there. So if you haven't run a load or done the things right, and you get into court of law, it's not going to be good. This goes all the way back to, I think, 2005 when 13 SEER equipment came out. Don, I'm going to let you play the role of the contractor here. Okay? This is a mock court case is what this was. Don, are you licensed to install heating and cooling equipment in this state?
Yes.
When did you first receive a call from Miss Senior informing you the new air conditioner you installed would not cool her home to 80 degrees?
I installed the unit in April but didn't get any calls until mid-June.
Did you include a new evaporator coil with Miss Senior's new 13 SEER unit?
No, Miss Seniors was a good customer. I wanted to save her some money because I got the new unit installed the same day her old compressor died.
Did the equipment manufacturer and distributor both recommend the evaporator be replaced with every 13 SEER unit?
Yes, but I've always had good luck using existing evap coils because it would have taken at least 2 extra days to get sheet metal made for a new evap.
How many times did you go to Miss Senior's home in an attempt to get the temperature below 80 degrees?
5 or 6. We were about to get it fixed when Mrs. Seniors called another contractor. I heard that he charged her over $4,000 to fix the same ductwork and install a furnace and evap.
Did you do a heat gain study before installing the new air conditioning unit?
I didn't need to. Her old equipment was big enough and big enough to heat and cool just fine.
At any time, did you inform Miss Senior that without the right evaporator that she would not receive a full 13 SEER in energy savings?
I'm not sure. That was a long time ago.
Would you please read the line circled on the contract between you and Miss Senior?
Install new 13 SEER high-efficient unit.
From what you just read, do you feel Miss Senior was led to believe she would receive 13 SEER worth of energy savings?
I didn't tell her she would get a 13 SEER. If she assumed that she would get a 13 SEER, it's not my fault. I sure didn't promise her anything.
Are you aware fraud can be committed by false suggestions, innuendos, or even silence?
I don't know, but I'm sure my attorney can answer that.
As a licensed contractor, you're deemed to be an expert on heating and air conditioning. As an expert, is it possible for mold to grow in a home that is not properly dehumidified?
It could happen.
Do you remember when Miss Senior first called you about the mold in her home?
Sure. The 4th of July, we were swamped. I told her we'd get to it as soon as possible. If that's what you're getting at.
Did she tell you the mold was making her sick?
Come on. That mold has been there for years.
Would you please explain to this court how, without doing a heat gain study to prove the correct size, you can install a new 13 SEER unit utilizing a 17-year-old evaporator and expect it to remove enough moisture so mold would not be likely to grow in Miss Senior's home? No answer from the contractor on that.
Ladies and gentlemen of the jury,
So that's the kind of stuff you would get, you know, in the court of law like that. So demonstrate due diligence in the court of law. Provides the design values for sensible and latent equipment capacity, which is what we need to satisfy. We need to satisfy both the sensible, which is the temperature that the thermostat sees, and the humidity, which is what the latent is going to remove from that. That's why I like that Honeywell thermostat. It shows it does both. Consequences of failing to make a detailed and accurate load estimate. Discomfort during design day. Produce marginal or unacceptable comfort at part load conditions. Reduce the equipment's ability to control indoor humidity. Cause short cycling, affecting comfort, operating cost, and reducing the equipment life. Translates to large equipment and ducts. Increases the installed cost, resulting in less competitive quotes. Increases the loads on the utility grids, and an awkward position in a court of law. The business issues. You know, it shows to your client that they are important to you versus somebody that can't produce, you know, a rule of thumb that it takes this size unit. Well, I've always installed a, you know, 3-ton unit in an 1,800 square foot house. Well, glass, and a lot of different things has an effect on that. It shows them you're selling quality, performance, and dependability. The comfort system is professionally designed and exceeds the minimum standards and practices. What little bit of time you spend on the design work, probably save that on by putting in the cheaper unit and a little bit less duct work. So although I might have to spend another hour or two doing design work and I can charge for that, I'm selling them a 2.5-ton versus the 3-ton unit and possibly smaller duct work. Value-added work. You can be trusted to do the things the right way. You show you care, and you make money. This is the design process. Load calculation. Your system concept first, which is when you meet with the homeowner, but the load calculation, the manual J, the equipment selection, manual S, and the duct size calculation, manual D. Those are the three that the codes, written into the codes, they're requiring. An accurate load calculation. There's some mandatory do's and don'ts. The do's. Make sure you use the outdoor design conditions recommended by Table 1 in Manual J. Although we're finding that a lot of code jurisdictions are requiring something a little bit different than what's in the Manual J. Not much, 2 or 3 degrees. In other words, if it's a 92 degree design, they're saying go ahead and design it at 95. So giving you a little leadway there on it, but it's not a lot. So it's either the Table 1 or whatever the codes has in that. Use the default indoor design. The default indoor design is 75 in the summer and 70 in the winter. So if you put 70 in the summer and 95 outside, that's a 25 degree temperature difference. You know, you bump the load by 20% if you do that. So use the recommended indoor design. We have people tell us, I want it 68 degrees inside. Consider the orientation of the structure. A lot of people run them at worst case. They'll put most of the glass is typically on the back side of the house with French doors and sliding glass doors. That's the worst orientation, and they'll always put it facing west. You know, try to take the exact orientation. If that back side's facing north, you know, take advantage of that. Because I'll show you in a minute. I'll take the same house and I'll run it worst case, and then I can run it best case. And I can get it down to a 1.5 ton, or I can get it up to like a 4 ton just by rotating the house and putting the ductwork from the crawl to the attic and leaky ductwork. So make sure you know the orientation and run the load calculation with the correct one. Verify all construction details prior to calculating the loads. What insulation values are we going to use? What type of sheathing? What type of windows? You've got to have all that information to feed into the load calculation program. Not just guessing and rules of thumb there either. Take full credit for any internal shading devices or external overhangs. So you got an overhang on the front of the house. Depending on the direction, it's going to cause a shade line on the window. Any glass that may have a big porch over it. So any glass that's got a shade line on it is figured as north-facing glass. So because north-facing glass never sees the sun, so we calculate it as north. Use internal shading devices that are compatible with the type of room. You know, if they've got going to put blinds up, these plantation shutter blinds, they seem to be real popular these days. I always figure private rooms like bedrooms fully shaded. And I tell them, I said, when it's the middle of the summer, you need to close the shades, you know, in there. You've probably got them closed at night anyway for privacy purposes. Just keep those shut. But I got a lake or a pond out back, and I put all this glass in so I can see it. So, you know, consider that as well. There's not going to be any shading on that type of windows or glass. Take credit for insect screens when they're installed. That adds a little bit of a shade factor on the external glass. Take full credit for the rated performance of construction materials, insulation, and construction features. Like if it's got windows and they got a sticker on it, use the rating that's on the sticker on there. Take full credit for the tightness of the envelope construction, and that's going to kind of be dictated by codes now. There's 5 levels. It's like tight, semi-tight, average, semi-loose, and loose. Older houses were probably in the average or semi-loose. So at a minimum, you'd want to go to the semi-tight. Depending on the contractor and the type of work he does, you may want to go tight on it as well to take full advantage of that. And then follow the manual J procedures for infiltration and ventilation, not trying to bump that up. Take full credit for duct system sealing and insulation, which, see, that's now part of the code. Got to be sealed. Insulation, mandatory. One of those court cases we went to had absolutely one of the best looking duct jobs I've ever seen. Everything level, right angles, and straight, but they used homemade tapping collars. They took a short piece of round pipe and they cut it with snips. They turned one out, and you could stick your finger in some of them. Nothing was caulked, nothing was sealed. The insulation was pulled so tight. That's why it looked good. It was pulled so tight, you know, it had no R value on it. So when I figured all that up, the manual J was okay with what he put in, but then when I showed the deficiencies in the insulation and the leaky ductwork, poor insulation, I mean, I measured the return temperature at like 75, and we should be getting about a 20-degree drop. I was only getting like a 12 or 13. I was losing 35–40% because of that ductwork being in a hot attic that was poorly insulated on that particular job. There's a inspector up in Hendersonville who has a broomstick with a nail on the end of it, and he's got it marked, and he'll go around and he'll punch your insulation, make sure you got the proper compression on it. He'll go around and he'll touch your ductwork to make sure you hadn't got that, you know, compression on it. Dean, you know Dean? Okay. Dean Martin. Match location is possible when selecting the duct load table. You know, the ductwork is going to be in the attic. Is it a radial system, a trunk and branch system? Is it in the crawl space? So look at the duct tables and try to get the one that closely matches the type of duct system that you normally put in. There'll be one in the attic with ceiling center outlets, and there'll be one in the crawl space got perimeter outlets. Match the duct system and return system geometry. Use the correct R values for the duct wall insulation. Blower heat. If the blower motor is sitting in that airstream, so if the manufacturer has not already accounted for that, then it's got to be added. That motor is generating heat and putting it back into the airstream, roughly about 1,800 BTU. So need to account for that as well. So you got to look at the specific manufacturer to see if it is included or not included in his final numbers that he gives you to select your equipment by. Don't. Manual J is not for commercial applications. Commercial applications uses manual N. Manual N. Do not use MJ8 to estimate loads that are not compatible with the overview of this manual. That's where I said if it's a big, you know, then you need to go to the big book, not the abridged edition, the long form versus the short form. Do not design for record-breaking weather, just like we had this year. This July is the hottest we've ever had on record here. So we still can't design it. I know people, they suffered a little bit, but you know, if it's 80 degrees inside and it's 100 outside, that's still not, you know, not too bad. We're trying to guarantee roughly 20 degrees difference from the outdoor temperature to the indoor temperature. Do not add a safety factor to Table 1. That's for the design conditions, like I said. Do not design for abnormally low or high indoor temperature or humidity conditions. 70 for heating, 75 for cooling. And do not assume there is no internal shading. That's where the interview with the client comes into play. You know, what type of are you going to use shades, blinds, nothing? You know, get all that worked out on the front end. Here's an arguing point on this one. I say, well, what happens when they sell the house and the next person moves in that house and they choose not to use any internal shading? Like I said, that's an arguing point there. Do not fail to take the full credit for overhangs. I mean, there's a lot of big porches, just entrance foyers. Sometimes they'll have covering on them, and the side lights and the glass on the door would be shaded. A lot of popular now is outdoor living areas. I mean, it's covered, and there's lots of glass that goes out into that area, outdoor fireplaces. So that's all under shade. So that would be north-facing glass. Old way was you walked out onto a deck that was, you know, in the sun, and you got a lot of sunlight on that glass. Do not assume that the load for the worst case site orientation can be used for other orientations. We talked about that earlier. Take a compass or know which way it's facing. Do not reduce the known ceiling, wall, or floor R values just to be safe. They're going to be checked by the building inspector to make sure they're in compliance there, so you're safe on that one. What are you doing about quality? Quality control of installation of insulation. You're going to call the builder out on that too. If there's voids and gaps, and like we talked about, if he tucks it behind wires and tucks it behind boxes, and that'll all be covered. It's just that's what we, you know, if that's not done, then like I said, if it doesn't cool, then what happened? I had one time where he forgot to put the attic insulation in. It wasn't cooling. You go out, I'm like, what's going on? You go out and no attic insulation. I've had some that they forgot to put. There's no ventilation. No ventilation in it. You go up in the attic, it's 150 degrees, and that's where the ductwork is. You couldn't hardly breathe in it. So, yes, sir.
Since you're asking about how insulation is going to be inspected, that's going to be a sticking point as an HVAC contractor, because if the inspection doesn't call the insulating contractor on the carpet for getting it right, and it passes, and it's covered, we size based on actual R13, R32,
Right.
and so forth, and if it doesn't cool during design condition, how do you prove? That's where it gets sticky with the AC contractor. So the question you asked as a building official becomes critical to us, because we can't go back and prove this. He pulls out his inspection report and say, I passed. My insulation's fine, your unit's wrong. So you see the point I'm getting at is if we size to those insulating values, but in reality those values are not really there in the walls, the floor, and the ceiling, we can get into difficulty. I'm not saying we shouldn't. I'm just saying that's where the disconnect can happen between
That-
reality and the code and what we put in.
And that's been the history of the past, is no guarantee on infiltration, no guarantee on the quality of the insulation. So this 500-600 square feet per ton rule may, kind of protect you in that situation. But I mean,
Companies go in the direction of they're going to pad it a little bit.
yeah.
They don't
Well, I think they're committed, to following the code and make sure the insulating contractor. You got a digital camera and you see it. Everybody's got smartphones these days. Take a picture of it. It's nothing any better than taking a snapshot of it and email it to them. Say, hey, here's, we noticed this. We noticed tees or corners aren't getting insulated or whatever. But I don't know if it doesn't cool in the end, and there was ever, an inspection to go back in, and that kind of stuff was uncovered. I don't think they want to have any liability for that.
No, I'm not saying they're not wouldn't try to do their job. I'm just
Right.
saying that there can be a disconnect in that, especially like new inspectors that are being trained. This seems to be a new program we're headed towards, getting
Right.
this insulation up to where it should be. And so there's going to be a learning curve on everybody's end of it.
There.
On the builders as well.
Yeah, there's a little safety factor built in to this. Probably, to a certain extent.
They do it right. They sent it with DOS, so.
Yeah, good. Good deal.
And I understand, because we've only been inspecting or enforcing the energy code for less than a year now. And we're still learning how important it is to insulate correctly. And we'll get to a job site and say, well, we got to fail you because you didn't put a bead of caulk here, you didn't do this, you didn't do that, and pretty soon the contractors are screaming at us, and we're trying to do right, but you know how contractors are. You got to bring them along slowly. You can't, just like you're subcontractors, we got to bring you along slowly but I agree, at least on my part, that I need to get better, my guys need to get better about, not being a hard butt about insulation inspections, but we need across the board to make sure it's done correctly. But we're this first year, we're trying to slowly teach them the right way of how it has to be done. And then when it's done correctly, then you guys will be able to size correctly.
And I appreciate that position, because it's tough. You guys get beat up for you saying it's got to be done this way. But the reality is,
Yep.
if it doesn't get done that way and we go on that number, we're cooked.
I agree.
We don't get those numbers out of the actual building.
When we did the introduction of the energy code, John said, well, let's talk about the mechanical side of it. No, let's get this process going. I think we're about there. There may be something that slides through the cracks, but I think we're just about there. So now we can come back to you and say, trust us to do our job to the best of our ability. We're going to screw up somewhere. Everybody does. But we're going to try to make sure
The code allows for 15% oversizing. So there's a little that make, you know, because it never, you know, we buy units in 6,000 BTU increments. So, you know, if it's a 31,000 BTU load, we're probably going to be putting in a 36,000 BTU unit. So you probably should have a little extra capacity for, you know, the insulation. That would be one of the minor. The infiltration is bigger.
You recognize from the one example you gave, the man was able to get it down to 2 tons.
Yeah.
Every little bit adds up.
That's right.
If your infiltration is off,
Right.
if your R values are off,
Right.
those 2 things right there will get you a half a ton in half a minute. Recognize that's the reason.
The big, I can show you the biggest things is glass. Doing glass wrong, and then where the ductwork is located, if it's in the crawl space or it's in a hot attic, and how good it's insulated and how leaky it is.
You can account for those things. Though.
Right.
The other things, what I'm talking
Right.
about, is when it becomes drywall.
Right.
You can't see it anymore.
Right.
Now, that was what I was going back.
Well, they do make, you know, infrared cameras. That you can go back in and identify those type issue. Yeah, I tell you what, we are a firm believer in spray foam insulation. It's just like believing in this and doing it right. After doing enough of these spray foam jobs, we're now in the spray foam business. We spent $45,000 for the rig, and we're spray foaming houses now. So that's right. That's right. We've bought So we've gotten into, you know, I think that's a good business for HVAC contractors to get into. Some choose to get into plumbing and electrical, building performance, especially on existing houses. So we bought the infrared camera, we bought the duct blaster, we bought the blower door, the camera, the spray foam rig. We're blowing attics. So we're yeah. But that could help if you got to go back in, and maybe you could spot where the heat's moving on. Yeah. Do not fail to give full credit for the builder's efforts to produce a tight envelope. Exactly what we're discussing. Should have went one more slide on that. If a local code specifies a fresh air requirement, do not assume the infiltration rate will satisfy this requirement. So we're getting these houses so tight now that we got to introduce a little bit of fresh air back in. So we're spending money to save on the infiltration, but from a health standpoint, in states like California, it's mandatory now that they always have to add fresh air in on it. So that's typically up to the local codes on that if they choose to. I don't get this one. Do not assume that windows and doors will be open when making the infiltration estimate. On commercial, they look at the opening and closing of doors for infiltration, but not on residential. So they say a door is going to open and close 10 times, and there's a different formula for that on the commercial side, but we don't do that on the residential case. Do not make the worst case. Everything is going full blast. So you're cooking, you got 10 people there, it's 3 o'clock outside. All that's not going to happen, you know, at the same time. That's why there's still a little bit of a safety factor there. You know, we figure so much for appliances, the people and everything, but all that's not going to happen. Typically our peak is around 3 o'clock on an August day. That's our hottest time we're going to hit. And it doesn't always happen all at the same time. Do not add extra occupancy loads for entertaining groups of people, just like the guy that wants to entertain. And I always tell him, I said, you know, you're a good candidate for two-stage equipment. I like to sell that two-stage equipment. That way you've got the extra capacity when you need it. If not, it's going to run down. And most times on that 80, 85 degree day, that's even better. So you kind of got the best of both worlds on two-stage equipment. It's kind of like driving a car. You know, you slam on the accelerator, and you slam on the brake on our conventional systems. Or if you've got variable speed or that, it's going to, put itself to whatever the load on the house is. Do not arbitrarily assume that the ducts are unsealed. Do not fail to give full credit for efforts to provide a tight, properly insulated duct. We're seeing that on existing retrofit jobs. I mean, people are inquiring about cleaning their duct work. I'm like, you really can't clean duct work unless you want to spend $900, $1,200. $1,800, I can put you a brand new, sparkling clean, sealed, insulated to code duct system in. So why do we want to put a new 18 SEER unit on an old, leaky, poorly insulated, dirty duct system? So there's opportunities to sell new duct systems as well on existing home situations. Insulation's falling off of them, they leak, it's just, and then we're trying to put high efficiency equipment on it. Just doesn't make sense to me. So you can add $1,800 to your sales ticket, real easy, or more. That was just an example. I know we had one, recently. Do not apply any safety factors during the or at the end. Improper practices: do not use rules of thumb, square feet per ton. Know the software that you're using. One of the other cases I had to go to court was they did run a manual J using one of the well-known software programs. They just didn't know how to use it. Didn't know how to set the defaults up. It was just a mess. So when I ran a correct manual J and you laid them side by side, hardly anything in there was correct. So you just can't take somebody and sit them down in front of a computer with the software and then they know what they're doing. I know the one I'm talking about, you need to go spend 2 days out of the office and spend lodging and $1,200 just to learn how to use the software. So it's pretty complicated. But to do it, it's hard to do one by hand anymore. You could do the 7th edition by hand. It's hard to do one pen and paper anymore. So, okay, you want to take a little quick break here?